Okay, this is kind of a continuation of section 2.3. Remember, I'm going to ask you to talk about what is the purpose of dividing a polynomial using synthetic or long division. So be thinking about that as we are going through these problems, okay? Now, I want to do one more example of long division because that seems to be the one that is the most difficult out of the two. So, I'll give you the problem, and my suggestion to you would be to go ahead and write it down, pause the video, and try it. Okay. Before I go through the example. I'm hoping when you look at this, we talked about the purpose in the last video being that I can find factors of this original polynomial. And I'm hoping that you notice there's no way that x plus 1 is a factor of that polynomial, okay? Now, we can still go ahead and use long division in order to find the factors, but x plus 1 is not going to be a factor. So we are going to have a remainder for this one. So now would be a good time, pause the video, see if you can do this long division problem. Okay, so the first thing I want to start with is canceling this x squared. What times x is going to get me x squared? Well, I know that's x. I'm going to go ahead and write it above my other x term. So now I go ahead and do x times x minus x squared. I always put the parentheses because I know I need to subtract. And then x times 1 plus 1x. X squared minus x squared should be 0. 3x minus an x should be 2x. I go ahead and bring down my next term because I know I have two terms over here. So now x times what up here is going to help me cancel a positive 2x plus 2. So 2 times x gets me 2x. 2 times 1. Remember, those are being subtracted. So I've got 2x minus 2x is 0. 5 minus 2 is 3. I have a remainder of 3. Okay? This still helps me to factor that original polynomial. Okay? So let's go ahead and write out our two ones. What was my answer to my division problem? Well, here was part of my answer, x plus 2. Okay, now how do I show that there is a remainder of 3? Well, I need to show that in addition, there was this remainder of 3 that I divided by x plus 1. So that's how you show a remainder, right there. You write what you have left over what you were dividing by. Okay, now, how do I write this in factored form? Oops, not formed, factored form. Writing this in factored form, you still are going to have your answer. Okay, I'm still going to have what I divided by. And then I just need to show that there was a remainder. In this case, it was just a 3, plus 3. So that's what happens when the remainder is not 0. Okay. Okay, so I want to talk about synthetic division. Okay, synthetic division. Okay, synthetic division is a great shortcut from long division. Okay, so it's only used when you have factors that are just x minus k. Meaning you have to have linear factors. You can't be dividing by x squared or something like that, okay? So to divide our polynomial, we're going to call it ax cubed plus bx squared plus cx plus d by x minus k. You use the following pattern. And I'm going to have to go on another sheet of paper, okay? Stick with me here. I think this will make a lot more sense when you have an actual problem. So just stick with me, okay? I'm going to try to do it here. Your k factor is going to go here. And then what goes in here are all your coefficients. So A, B, C, and D. Remember, those were the numbers that were in front of sorry, I just want to make sure you can see. Remember, those were the numbers that were in front of my x terms, okay? So what I'm going to do is I'm going to bring my a term down, okay? And here's the pattern. When it's diagonal, you multiply. So here, I'm going to do k times a. And that's what's going to go below b. When it's a vertical, so right here, I'm going to add those terms together. I'm going to get a term here. And then I'm going to again multiply by k. That's going to go below my c. Then I'm going to add. That's going to go below my d. Okay? So, when it is diagonal, you multiply. Vertical, you add. Okay? So let's just go ahead. We're going to try an example of this. Okay. So synthetic division. We're going to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. So first we need to set it up. And inside goes all of my coefficients. So I have -1. Now notice here, this goes from x to the fourth to x squared. I need to account for the fact that there's no x cubed. Then I've got minus 10x. Then again, I have x squared to x, so I'm okay. And then 4. Okay. Now what goes here? Some of you would just say 3. But if you remember, it has to be factors that are in the form x minus h. So that means that is really a -3. Okay. You also can think about it as -3 is what the solution to that would be. Okay. So I go ahead and I'm going to bring down, oh, and why did I write a -1? This should be positive. Sorry. That should be positive. That was a positive coefficient. So I'm going to go ahead and bring down the 1. Okay. Now I'm going to do 1 times -3. That's -3. 0 plus -3 is -3. Negative 3 times negative 3 is 9. Negative 10 plus 9, negative 1. Negative 3 times negative 1, positive 3. Add those together, I get 1. Then I have negative 3 times 1, negative 3. I have 1. This is my remainder. Okay, now, how do I know what all of this represents? Because right now it's just a bunch of numbers. Well, this is my remainder, and just like I wrote my previous answer when I had a remainder, it would look like that. Okay, now, this is just my constant term. Okay, here, this is my x term. So, 1 is added minus x. Here, this is my cubed term. And this would be my, or not cubed, that's squared, then cubed. Okay, so you have to kind of work backwards. Constant, x term, x squared term, x cubed term. So there would be my answer when I did that by synthetic division. Okay, this is still an x cubed, so I would not expect you to factor that anymore. Let's do one more example. And again, you might want to pause your video and try this one by yourself. So we're going to take that polynomial by x plus 3. Because that's x plus 3, I know negative 3 goes out here. It's whatever makes this 0. It's my actual solution to my factor. Okay? Then I set up my coefficients, paying attention to make sure I'm not missing anything. And I'm not this time. Okay. Now remember, vertically add, diagonally multiply. So first thing I have to do is bring down my a term. So then, negative 3 times 5 is negative 15. 18 plus negative 15 would be 3. 3 times negative 3 is negative 9. 7 plus negative 9 is negative 2. Negative 2 times 3 would be 6. So again, this last number represents my remainder. And here I have a remainder of negative 10. So I'm going to go ahead and write my answer, which would have been x plus 3. Oh, excuse me. X plus 3 is not my answer. Let's go ahead and write our answer to our division problem, which would have been negative 10 over x plus 3 plus, this first term is my constant, and it's got a negative sign. This is my x term, and this is my x squared term. Okay, we didn't do an example of synthetic division where we had a remainder of 0, but that will happen sometimes, and then we can actually factor a polynomial. So I want to come back to our guiding question, and what I want you to do right now, this is something you haven't had to do before, is this is your guiding question for tomorrow that you will be thinking about as you're working through your assignment. What is the purpose of dividing a polynomial using synthetic or long division? And right now what I want you to do is answer this question in your own words. Come up with a couple of sentences that you can be prepared to on Monday, okay, or tomorrow. Come in and talk to your group members about your answer to that question. What do we find out when we divide a polynomial using long or synthetic division?